So one of the things, the reasons why we learn logarithms is that it allows us to solve for unknown exponents and unknown indices. Okay, so this is done by what we do, taking log on both sides. So it allows us to take, if we take logarithm on both sides, this allows us to bring down our powers, unknown powers or exponents by using the power law. So yeah, a very simple example is something like that. If I were to have, for example, say, you know that if I have a log a x equals to log a y, we learned from the earlier videos that this allows us to remove the x and the two logarithms. It gives us x equals to y, right? But vice versa, they are also the same, right? If x is equals to y, then log ax is also equals to log ay. Okay, so this means that, you know, if I give you two algebraic terms, I take log on both sides. This allows me to solve sometimes for unknown exponents. Okay, so what do I mean? Let's look at this example here. Okay, if 5 to the power of x plus 3 is equals to 100, you can see that if I were to take, for example, maybe a log on both sides, let's say if I were to take a log on both sides, right? Straight away, right, I can actually bring my unknown exponent down. So by using the power law, right, I can bring x plus 3 to the front. This gives me x plus 3 multiplied to ln 5 to be equals to ln 100. Okay? Can so I mean, this is an algebraic term, x plus 3 multiplied to ln 5, and this is ln 100 divided by ln 5 equals to x plus 3. Okay? This is the same as x equals to ln 100 over ln 5 minus 3, right? Because I'm just bringing the 3 over, right, over to the right hand side. Okay? And solving this will give you the value, I think negative 0.139. Okay, just by pressing into the calculator. Okay, just by pressing into a calculator. Okay? Now, when you have e, in this case, if I have e to the power of x plus 3 equals to 4 power x, that is where it's easy for me, because basically what I can do is, when I see an e, right, generally what I do is I try to take ln. Okay, because e, if I take ln is log base e, and the nice thing is that if I take ln, you know, ln basically is log base e, and log base e of e will give you 1. So it's a very nice exchange, where if I take a ln, okay, you can see that if I take a ln on both sides, ln basically is log base e. Okay, what will happen is that, you know, ln e, and then if I bring x plus 3 to the front, then x plus 3 multiplied by ln e is equals to, I mean, same thing, I bring my x to the front again using the power law. This gives me x multiplied by ln 4. Okay, and what is ln e? Ln e is basically log ee, right? So log ee, which is your ln e, is none other than 1. So based on this, right, I hope you can see why I take ln on both sides in the first place instead of any other log function, log base 2, log base 10. When I see a base e, my preference is to take ln. Okay, because it allows me to, you know, very conveniently take away ln e, which is just equals to 1, right? So x plus 3 is equals to x ln 4. Now solving this is a very simple just a very simple algebraic manipulation. X ln 4, okay, basically this, right? This is like x multiplied to the coefficient ln 4. So ln 4 is like a coefficient of x. And if you're solving this, right, I basically bring my x over, and I have negative 3. Okay, and this looks very challenging, but this is basically just solving a very simple linear equation in terms of x. Now, if you factorize out your x, you have x bracket 1 minus ln 4 equals to 3. Do you realize this? You can actually solve for x by factorizing out the x. Okay, all this ln 4 is just a coefficient. It's just a coefficient, and x has a coefficient of 1, which is why I can factorize out x. So following which, just solving this, -3 over 1 minus ln 4, you should get your answer to be, let's see, 7.77. Okay? Thank you.